is called the tubercles, which is we named wave leading edge.
The major role of the tubercle at the leading edge is to increase the lift force on the paraglider wing.
It was like the first thing we saw that it has huge potential.
It happens not many times in your life as a designer that you can do these changes.
At the beginning of 2020, some guy in France tried to propose us to have some new science or future revolution, and Jin asked me to make some kind of project with some university. So I tried to find one university in Ulsan.
예, 저는 유니스트에서 기계과 교수로 재직하고 있는 김주하라고 합니다. 저는 기계공학과에서 일하고 있고, 제가 하고 있는 연구는 어떻게 하면 공기 저항을 줄일 수 있는가, 또는 어떻게 하면 양력을 늘릴 수 있는가, 또 더 나아가서는 어떻게 하면 소음을 줄일 수 있는가에 대한 연구를 실험을 통해서 진행하고 있습니다. The collaboration with the Gene Glider was started by preparing some research project which is funded by the Korean government.
And the first year was 2019, we failed. And the second year, 2020, finally we succeed.
So during the 3 years, we developed many interesting technologies about the paraglider, such as canopy or helmet, etc. So now I'm very satisfied with the collaboration with the Gene Glider.
The professor didn't expect that I will do that. In the beginning, he gave me datas, and then he never believed that I'm going to create these crazy things. And then he was very surprised that I do a lot of experiments through his datas. We understand better now each other, so the communication with the professor team really better. So that gives me a lot of potential. So he has a lot of students working in these projects together. So we have a lot of different projects going on with him.
Between the direction of the wind and the chord line of the paraglider wing. And this angle is called the angle of attack. And when the angle of attack is small, then the pressure underneath of the wing is much larger than the pressure on the upper surface of the canopy. That's how the paraglider wing makes lift force. Okay?
The theory is very simple. The leading edge, normally airflow is coming, and then right after you get the separation, and create the turbulence. But with the tubercles, because airflow is coming in the middle of these tubercles and bring all these turbulence more in the backside of the canopy, so your stall speed is quite delayed, and because of that you have more lift.
But the problem is that when the angle of attack is too high, then the pressure underneath of the wing is still high, but the pressure difference between the upper and lower surfaces becomes small, and which results in the reduction in the lift force. Okay? And if you apply tubercles at the leading edge of the paraglider wing, then the pressure on the upper surface can remain small even at high angle of attack. So the pressure difference between the upper and lower surface can be remained with large magnitude, and it will make the lift force generated by the paraglider wing remains large. Okay? So that's how tubercles at the leading edge of the paraglider wing works.
Through these wind tunnel tests, we discover that the distance in between the tubercles and the depth of the tubercles is relative aspect ratio, so that creates different drags.
You are very sensitive when it comes to these kind of new designs, for sure. Because with the other designs you're so used to it, you trust these constructions, or you know from the parameters, okay, this wing can be already borderline, and this takes a while until you build the trust like you have with your previous concepts. And when this comes then day by day, and especially when you start to recognizing the benefits, it's definitely outstanding. The biggest point for us anyway was, after we balanced everything proper and got rid of the first problems, how safe the wings became. So this was something which gave us a lot of trust also in the concept. If you have suddenly a new setup which allows you to change quite a lot of the parameters which were fixed in your mind, this is something you're dreaming of, I have to say. And it happens not many times in your life as a designer that you can do these changes. We have a few test pilots who are since a long time with us, like we have Tim Bollinger, Michael Siegel, and also our Korean test pilots. It's a very special situation at Jing Gliders because the pilots are coming from all over the world.
Sometimes we meet in Korea, sometimes in Switzerland, so it depends really on the season. And in wintertime we often go to Central America, like Valle de Bravo, Mexico, which is very, very good for testing. So we do this small test sessions to really get to know the gliders.
The idea with Torsten is more like to have really a plan from the beginning to the end. And after every day we are really focused what we expect about the gliders. And normally after 2 weeks we know if the prototype is able to be finished or not.
I think the feedback we are getting and the diversity we have, it's also quite unique. It's very often that you think the wing in this condition it's flying nice, and then I send it to Michael and Michael gives me a phone call and say, what the heck are you doing there?
It was the first prototype we had, and I was like, wow, okay, this is maybe not ready yet. And yeah, it was like the first thing we saw that it has huge potential. I mean, the performance was there, handling was not good, very high beat pressure and so on and so on. But those are things you can work on, and that's exactly what Jin did. And then he was testing again in Korea, more or less, and I got the glider last spring. And that was super interesting because that was the first glider I saw the real potential of the glider. we had this glider had a aspect ratio, I think 7.2 or something, and it had the same performance as another prototype that has glide ratio 8. So it was like, wow, okay, there is really something.
It's sometimes something where you definitely have to investigate and test it quite a lot to be aware that you have a proof of the concept, which is, I think, with our setting pretty good because, as I mentioned, we fly all over the world, we are traveling a lot, we have a lot of different places where we are working on the wings.
When you tested the glider in Valle de Bravo in the punchy thermals, you know the glider is stable and fast.
When we test, the manifold test for the Boom 12 was very easy. We finished in 1 day, not even 2 days to film for CCC class. There's a lot of things happening after the huge collapse. The glider has no tendency to shoot. We were surprised. So actually the tubercle is not only give you the more performance, but also about the safety. After collapse, the glider is never really aggressive shooting, which before we were always ready when we make collapse, and now it's coming. But with this, Boom 12 was super easy. I was not expecting that about the safety or stability. This is our bonus actually result. This tubercle was working in the whales, but to bring it to the industry is another work you have to do.
Our factories, main factories in China, but also we have one factory in Korea just beside of our office building. So that's why we can finish our development really fast. At the first time we produced the very leading edge prototype, the fabric of leading edge had a kind of bias direction. So that's why the tension was different in each panel. We found out that if we little bit twist on each panel to find the right direction, then the wrinkles and leading edge tension was better.
I'm not aware of how many prototypes he did, but I know that he made pretty a lot. Because it's a brand new concept, also the shape of the leading edge and everything was adjusted. It's really not so easy to do it.
Now the prototype revision was around 23rd. We also produced quite some quantity in one revision. We produced like 40 to 50 prototypes.
And actually manufacturing part was, we have a lot of skilled people in the factory, so it was not a big issue, but actually more to design the wings more stable to have this wave leading edge works. This was more work to match everything to fit together.
Yeah, when you think about the competition in the last 5 years, it was more or less no real development. It was we have several new wings coming up, which are in some ways very similar when it comes to the performance. So the first time we tried this concept in the competition, it's 2 years ago. It was Michael Siegel, he was flying it during a Swiss championship.
We got the gliders for the super final. Still, the glider was not 100% finished. We saw like we have to fly heavier because we're climbing very, very good. And finally, we got the final product in Brazil for the World Cup, and yeah, it was really good. Yeah, I mean, with 3 pilots on the podium, it's not that you see immediately that the glider is performing better, but it's not a coincidence that there were always the boomerangs in the leading gaggle all the time. So you don't see it, but we always had more luck than all the others, constantly. So, and that's a good sign.
I think the glider for this comp here, it's like a little bit flat in the middle and mountains around. I think it's really the perfect combo for this glider. You are able to turn in strong thermal and also in weak thermals, and the glider is fast and stable. Means I think it's really strong glider for this kind of region.
Usually the races are 2 to 3 hours, and to take care during 3 hours, it's not a big problem. But in cross country, when you fly 11 hours or 8, 9, 10 hours, shall I jump into the lee side where it's super rough, but the climb is probably good? Or if I do soaring in front and maybe not catch the connection, with an easy glider, you just jump into the lee side and you get up, and the other one is like, it's okay. I'm fine without.
My name is Timo Leonesi. We tried some 300 Ks FIA triangle, taking off from Coalessois, going to the west to Remusa, and then south near Saint-André, and then closing the triangle maybe a little near Italy, and then back. Speed and declared goal on FlyXC is 316, more or less 5 kilometers more than the past record, and the speed is 29.5 average on 300 kilometer course. Like all big cross-country flights, we try to take off like early, so the early morning conditions are quite weak, so it's always a difficult part. Need to stay high, keep calm on some slow climbs, and then we have some difficult part in this triangle, like the classic one, like we call now. All the Baroni, it's like quite complicated because if you get low, sometimes all the thermals are destroyed by the breeze. And then normally Saint-André is good. The way back is like crazy because we can go even if the thermals stopped. Can go only on the strong breeze of the valley and climb up and then go back to take off, and it's like really amazing. We did some landing at 9:15 p.m. so really crazy to fly after the sunset. It's fly very well. I think the biggest advantage for sure is in thermal, in turns, lift, and weak condition. Like the handling, it's similar to a low class category. And where I feel really safe with this glider is like when you are flying near steep face and rock, the glider do not attack really strong in front. But this glider just gives the information without power. In turns, it's like less physical. On the brakes, it's like easy. You get in thermals like at the end of the transition of all the time higher, so I think it's good.
it's much less demanding, it's climbing really, really good and so stable. So for me that was really a step ahead.
It's maybe a game change because the glider is really easy to fly. Why you don't use this platform or for other gliders like D and C class?
This project with the wave leading edge, it just started, and for me it's really interesting and I'm curious how it will evolve in the future.
Since we created Gene Lab, now we are doing lots of research which we never done before. We have now a really good platform. We have a huge potential to explore, and we are still working together with this university. We are doing now different harnesses and different things, even the helmets, even the arm fairings. I can guarantee that this is the future.